Hi everyone, welcome to another and our last segment on Chapter 6. In this segment, we're going to look at three important cost curves, which we've already seen, but we're putting them together and going to emphasize it again, because these are the ones we're going to carry through the rest of the course. We're also going to look at the total cost curves, and then what do we mean by cutting costs? And I suspect some of you have a pretty good idea, but I just want to clarify specifically what we mean in this class. So this is where we were last time. This is from our previous slides, where we see on the top, we've got total fixed cost, total variable cost, and those sum to give total cost. That should make good sense. Now, if we divide each one of these by output or quantity or total product, just the number of things produced, then we're going to get averages of some sort. So it should make sense if you take total fixed cost divided by output, you get average fixed cost. Total variable cost divided by output, average variable cost. Total cost divided by output, average total cost. And marginal cost, we said, is the change in total variable cost as a result of one more unit of output. So let's take a look at the cost curves that are so critically important to us. So once again, here's the critical ones, and we looked at this in our last segment, so I'll just breeze over it. Marginal cost, average total cost, average variable cost, and average fixed cost. But we're more importantly looking at these cost curves. So here is the same marginal cost. Here's the same average variable cost that we've looked at in the average total cost. So those are the three critical ones that we're going to look at for the rest of this class. So when we get into the next chapters, you'd be really good favor for yourself is to understand and learn these cost curves. There's a few key points. If you recall the point of diminishing returns, that's maximum marginal product. So up to this point where marginal cost is falling, the incremental cost of extra output is falling, that's because of the law of diminishing return, or that's because of division of labor, where we split up the tasks and each person specializes in a task. But then we do run into some sort of restriction of capital, and we hit the point of diminishing returns, and past that, marginal cost starts rising because of the law of diminishing returns. And then notice it cuts average variable cost and average total cost at the minimums. Let's look at this one called most productive output. That's our highest average product or our lowest average variable cost. Remember, it's the variable costs that we worry about here. So we call that our highest average product or our highest productivity or our most productive output. That's Q2, and that's occurring at the lowest average variable cost. The new one that we've got on here is called economic capacity. So we haven't talked about this one before. I'll put it in lime green. We haven't talked about economic capacity, and it's just a definition of the design capacity of the plant. The economic capacity is where average total cost is at its lowest. And intuitively, if you're building a plant or building a company, then you're going to guess at how much you think you might sell. And if that much is about Q3 worth of output, you'd like to produce that at your lowest average total cost. So you design your plant so that if you're producing Q3, hey, just what we planned to, that's at your lowest average total cost. So that is specifically defined as economic capacity. It's the quantity, Q3, where we reach our lowest average total cost of production. So distinguish between the minimum point on the average total cost and the minimum point on the average variable cost. They're very different meanings. With economic capacity, don't be fooled. I'll ask you now, can we produce more than the economic capacity? And the answer is yeah. You can produce at a quantity out here, a quantity out here, a quantity out here. Just if you notice, if I go up to my average total cost, these quantities are at higher than minimum average total cost. We can certainly produce more than the economic capacity, no problem. It's just we won't be producing at the minimum average total cost. So that's how that thing is defined. Now we also want to understand a little bit about how the total costs relate to each other, and we've got a good intuition on this. Total fixed cost, of course, is constant because that's how it's defined. It's our, say, our rent or insurance that we pay no matter how much we're producing, no matter if we're even producing zero. If we're still in business, our total fixed cost in this example is 30. So if we're producing 4 or 7 or 8, our total fixed cost right there is still 30 because it's fixed no matter what the level of output. So total variable cost, let's look at that one next. It starts at 0 because if you're producing 0, you have no variable cost when there's no output. So total variable cost starts at 0. Here, let me change that to blue. Total variable cost starts at 0. And as you produce more, you're hiring more labor and you kind of get this twisted total variable cost shape. And excuse me, that's due to the division of labor and the law of diminishing returns. So we're just really looking at these cost curves now. It should make sense that to get the total cost, you just take the total fixed cost and add it to the total variable cost. So this little black 2 arrows here between there and there, that's this distance right here. So that we just take and put right on top of the blue total variable cost curve, and that gives us the total cost curve. So the total cost and the total variable cost have the same shape, and the difference between the two of them is the total fixed cost. Okay, let's look at a table here, doing a little example where we take the output per day and they give us the total cost and we have to fill in the rest of this. It's kind of fun because you got to figure out that first initial step. So try and figure it out. I'll pause for a minute and see if you can actually do it yourself and then I'll go through it. But if this is total cost, 200, and we're producing nothing, what kind of cost is that? What kind of cost is that total cost? Remember, total cost is made up of 2 costs, total variable cost and total fixed cost. Well, we're producing 0. So there's no variable cost. So this total cost must be all total fixed cost. So the way you work this table is you plug in, notice they leave a space there, your total fixed cost, and that has to be 200 because we're smart enough to know that when we've got nothing being produced, we don't have variable costs. So anything in the TC category is just TFC. Remember, TC is equal to TFC plus total variable costs, and total variable costs are 0. So total fixed costs must be just the same as total costs. So we put it in there, and then you go, oh, it's fixed cost. So all of these are 200. Wow, that was good. And then what do we have to figure out next? Total variable cost. Well, I know that's equal to total cost minus my total fixed cost. Okay, all right. We're just working with this formula that we have up here, rearranging it. So I know total cost is 200. I know total fixed cost is 200. So 280 minus 200, well, that's 80. 340 minus 200, well, that's 140. 420 minus 200, that's 220. 520 minus 200, that's 320. This was a 0. 640 minus 200 is 440. And 780 minus 200 is 580. So we've got total variable costs. Okay, how do we get average variable costs? Well, just from the formula. And you've got it. We've done all 7 of them. Total variable costs divided by output, quantity. So what are my total variable costs? 80. Divided by quantity of 1 is 80. Total variable costs 140 divided by quantity of 2, that's 70. Total variable costs of 220 divided by 3, I don't know, but we just fill all those in. How do we get average fixed cost? Well, right from the formula, total fixed cost divided by quantity. What's my total fixed cost? Well, that's 200 no matter what. So this one's not so bad. 200 divided by 1 is 200. 200 divided by 2 is 100. 200 divided by 3, I'll let you do the math yourself and you figure all those in. What's average total cost? Well, that's total cost divided by quantity. Go to my first total cost. There it is, 280 divided by 1, that's 280. Here it's 340 divided by 2, that's 150, 60, 170. Then we go up here, total cost is 420 divided by 3. I'll let you do the math. The marginal cost. That's the change in total variable cost divided by the change in quantity. So I'm going to go from a quantity of 0 to 1. Total variable cost goes from nothing to 80. So that's 80 divided by 1. So my marginal cost is 80 there. Let's do the next one. It's more interesting. My output still only goes up by 1. That's what I'm going to divide by. But the total variable cost goes from 80 to 140, which is now 60. So 60 divided by 1 is 60. And we fill the rest of those in. So I'm just going to clear this, go on, and click ahead and fill in the tables. So they start and they give us fixed cost, great. Then we calculate total variable cost like we did, then average variable cost with the formula, then average fixed cost, then average total cost, and then marginal cost. And I'm not going to point out too much, but notice average fixed, average variable, average total, and marginal all fall and then rise again, just like we'd expect them to do. We started out this segment by talking a little bit about cutting costs and saying most of you might have an idea. And I would actually venture to say that most of you don't, as you're talking specifically about this class in economics. Because if I asked you, what's the single best way to cut costs? I suspect more than just one of you might say, well, you just lay people off. And sadly, that's what happens. That's what's happening right now in this economy around the world during the COVID crisis here, is that people are laying off and they don't want to cut costs that way, but they have to. What we're referring to here is something a little nicer. We're looking at a reduction in average costs, not total costs. If we lay everybody off or just produce nothing, we really reduce our total cost, but that's not what we want to do. We want to reduce our average cost. Now, there's an assumption we always have in place, and we're always assuming the firm is assumed to be producing at the lowest possible average cost for each output level anyway. So they're already, on that average total cost curve. So we can look at two things. We'll look at this one on its own, but these first two, if the price of a fixed or variable input decreases, they're saying our costs will decrease. So we want to draw a picture of that, but just think, what if I went out? What are my fixed costs? Well, there's lots, but I'm just going to say, what if I went out and negotiated a lower rent? Then my fixed cost goes down. So therefore my average fixed cost goes down and my average total cost goes down. All right, well, there's variable inputs too. Couldn't I go out and just negotiate a lower salary? So if I just tell everyone, look, we're hurting bad, and that's been done before, certainly in Alberta in the oil industry, where they just say we have to cut everyone's salary. Well, they've just lowered a variable cost. So therefore they've lowered average total cost and the cost curve shift. So we'll take a look at that. Also, the marginal product. So if there's some way I can come into my little picnic table making business, slap everyone on the back and smile and compliment everyone on the clothes and how happy everyone is, and all of a sudden the productivity increases because it's such a positive work environment, and you produce more picnic tables that day than usual. Well, it didn't cost me anymore, but I've helped increase the marginal product. So the average cost of producing those picnic tables has dropped, because I'm using the same number of people, only I'm producing more picnic tables. So both of those things will lead to a lowering of the average costs. And that's what we're trying to show. There's our average costs. And if you look at MC1 and ATC1, that's where we start. And if I've been able to negotiate lower rent or a fixed cost, then my average fixed cost and average total cost will drop. If I'm able to negotiate lower salaries, then my average variable cost will drop, which will also cause my average total cost to drop. So when that happens, remember the marginal cost is connected right at its minimum. So MC2 falls along with it. So the conclusion is, if you get lower input prices somehow, that'll shift the cost curves down, both together. Now I'm going to take a look at the one other point that they have on that page, and draw that separately on the whiteboard. So have a look at this last statement. A firm is operating at excess capacity. I want to change that word to with excess capacity, and then it increases output. How the heck does that lower average costs? So that's what we're going to draw. Just think of this though, keep it in mind. The firm is operating with excess capacity. You have to put in your mind right now, where is capacity? Where's economic capacity? That's the minimum average total cost. So they're operating at excess capacity. That means they're operating with excess capacity remaining, and then they increase output. Let's take a little picture of what might happen in that scenario. Okay, so here we are. I drew the picture ahead of time, and I want to show that we're operating with excess capacity or at excess capacity. So right here is the quantity of output at economic capacity. So I'm going to write econ cap. Normally we just go QEC for economic capacity. Remember that was defined just a couple moments ago. It's the lowest average total cost. It's the quantity being produced at the lowest average total cost. But in the scenario, that last point says we're operating at excess capacity. So that actually means we're operating at an output Q1. And if you look, what's my average total cost if I'm producing Q1? Well, it's up here, ATC with 1. So what we're saying is that this distance there to there, that's our excess capacity. And that's because, well, capacity's up here at QEC, but we're producing at Q1. That's the scenario they're starting with. And then they say, well, if we increase production, we'll lower costs. How can that make sense? Well, let's try it. Let's go from Q1 just out to here. Then I go up, I find ATC, and I come over, and this is the second ATC. And yeah, costs went down. We moved along this curve. So let's increase output one more tranche to there. And notice we've come all the way out to here. If I go up from that quantity and come across, and now we're at ATC minimum. That's critical. So we've got to our economic capacity output in our minimum ATC. So if we start back at Q1, they're exactly right. They said if we're producing with excess capacity, so we're producing Q1, which is less than our economic capacity quantity, and we increase output, which we did with these two little short green lines, then we move down this cost curve and we've decreased our costs, just like they said they would in that statement. So that's all we wanted to show in this chapter. That's the end of this segment. And in the next chapter, we're going to start talking about costs in the long run. This chapter was all about costs in the short run. So we will see you when we get there.